Hello everyone, welcome back to this YouTube channel, IBwontcrushyou, and the topic of today is trigonometry from the chapter Geometry and Trigonometry, and we will go through some problems to make sure that you understand all these concepts. Problem 1. A ladder is laying against a vertical wall. The ladder is 5 meters long and makes an angle of 65 degrees with the ground. A. How far up the wall does the ladder reach? So let's firstly draw our situation. So here we have the ground, here we have our vertical wall, and we have a ladder that is leaning against a vertical wall. So we know how the ladder lies. So this is our ladder, and ladder is 5 meters long. So 5 meters in here. Here, of course, we have a right angle because we know that when we have ground and a vertical wall, so they make a right angle. And we know that the ladder makes an angle of 65 degrees with the ground. So in here we have 65 degrees, and we know that the sum of the angles in a triangle has to be equal to 180. So here we have 25 degrees, and we have to calculate this distance, because how far up the wall does the ladder reach. So we can use sine rule. So this side x over sine 65 degrees equals, and something that we have, the length that we have and the angle that we have, so 5 meters over sine 90 degrees, and we have to calculate it on our solver, and our answer is 4.53 meters. B. If the foot of the ladder is moved 0.5 meters further away from the wall, what angle will the ladder now make with the ground? So we have to imagine, or basically we can draw it, that our ladder is moved away, like here. So here and here we have new angles. They are no more the same as in A. Here we have B. Here, of course, we have right angle. We know that the length of the ladder doesn't change. And let's firstly calculate this distance, because we know that it's moved 0.5 meters. So we can calculate this distance and then add to it 0.5 meters. So we can calculate it from the Pythagorean theorem. So 4.53 squared plus y squared equals 5 squared. So y is 2.12 meters. So this distance, let's denote it as z, is 2.12 plus 0.5, so 2.62 meters. So 2.62, and of course we can calculate also this height. So also from the Pythagorean theorem, 2.62 squared plus h squared equals 5 squared, and h is 4.26, so 4.26 meters, and we are looking for this angle because this is the angle that the ladder makes with the ground. So we can simply find it from the sine rule or from COH, CAH and TOA. And if you don't know what is this, you can see it on my channel as the first short, so you can see it here. And now we will use just our sine rule. So we're looking for this angle and this, and we have this side. So 4.26 over sine alpha equals, and the side that we have and the angle that we have, so 5 over sine 90 degrees, and alpha is 58.4 degrees. Problem 2. A triangular park has sides of lengths 120 meters, 85 meters, and 95 meters. A. Use the cosine rule to find the largest angle of the park. So firstly, let's draw our triangle to see which angle will be the largest. So this is our triangle, and we can observe that the largest angle is opposite to our longest side. And now we have to use the cosine rule to calculate this angle. So cosine rule looks like this. Cosine of the angle equals a squared plus b squared minus c squared over 2 times a times b, and this formula is in your booklet, so you don't need to remember that. So maybe let's denote this angle as c. So we have cosine c equals, so this side is c, this is a, and b. It's necessary that our angle C is opposite to side C. So in here we have angle B because here we have side B and here we have angle A. So then we have A squared, so 85 squared plus 95 squared minus 120 squared over 2 times 85 times 95, and we have to calculate our angle C, and our angle is 83.4 degrees. B. Calculate the area of the park. So we know that our park is in the shape of a triangle. We cannot use the regular formula for the area of triangle 1 over 2 times a times h, because we don't know the h. We can simply use the formula for the area of triangle in the section of geometry and trigonometry, so 1 over 2 times a times b times sine c. So we have 1 over 2, and we take these sides, so 85 times 95, and times sine c, so the angle between them, so times sine 83.4 degrees, and we have to calculate it. So the area is 4010.74 meters squared. C. A straight walking path is to be built across the park, dividing it into 2 triangles by connecting the vertex of the largest angle to the opposite side. Find the length of this walking path. So in here we can have 2 interpretations. Firstly, our straight walking path from the vertex to here, so we have 2 right-angled triangles, or we can also interpret it as the vertex to the midpoint of this distance. However, we will solve it with our first interpretation, so with 2 right-angled triangles. So basically this is our height of the triangle. So we can simply solve it by using formula for the area of the triangle, however the basic one. So 1 over 2 times a times h. We know that the area is this, so 4010 and 10.74 equals 1 over 2 times a, so 120 times h, and we have to calculate h, and this is 66.8 meters. Problem 3. From the top of a lighthouse 30 meters high, the angle of depression to a boat is 12 degrees. A. Find the distance of the boat from the base of the lighthouse. So firstly, let's recall what is the angle of depression and what is the angle of elevation, because we have angle of depression and angle of elevation that can appear in this kind of problems. So the angle of depression is when we have straight line, and here so let's imagine that we are in the airplane, for example in here, so we are in the sky, and here we can observe a human, so this is angle of depression. And when we have the ground and we are this person, and for example here is an airplane, and this angle is angle of elevation. Okay, so now we can draw our image. So we have to find the distance of the boat from the base of the lighthouse. So we know that from the top of a lighthouse 30 meters high. So let's imagine that here we have our lighthouse 30 meters. Here we have a stop, and from the stop the angle of depression to a boat is 12 degrees. So here we have our sky, and here we have our angle of depression, so 12 degrees. Here we can make our line longer, and we know that it forms a triangle right angled. So of course here we have 78 degrees, and here of course 30 meters, because this side is the same as this side, and of course this is the same as this. We have to calculate the distance of the boat from the base of a lighthouse, so basically this distance, but we will find this distance because they are the same, and this distance, this one is in our triangle, so it will be easier to find it. And we can simply use the sine rule to find this length. So we have 30 over sine 12 degrees equals, and we have this side over sine 78 degrees, and from this we have our length 141.14 meters. B. If another boat is observed at an angle of depression of 25 degrees, how much closer is this boat compared to the first one? So we know that if we have a greater angle, so our distance from the boat to the base of our lighthouse is closer. So let's firstly draw our image once again, however with this new angle of depression. So this is our new drawing. We know that the height of the lighthouse doesn't change. Here we have 25 degrees, so here we will have 65 degrees. Here of course we still have the right angle, and once again we are looking for this length. Here of course also 30, so we can once again use the sine rule. So we have 30 over sine 25 degrees equals, we have x over sine 65 degrees, and we have to calculate our x, and x is 64.34 meters. So this is the distance, and we have to calculate how much closer is this boat compared to the first one. So all we need to do is just subtract from 141.14 our answer, so 64.34. The final answer is 76.8 meters. Problem 4. A triangular pyramid has a triangular base ABC with AB 12 cm, AC 14 cm, and angle BAC 80 degrees. The apex D is directly above point A such that AD is 10 centimeters. A. Find the area of the base triangle ABC. So firstly, let's draw our triangular pyramid to see how it looks like. So this is our triangular pyramid, and we have to calculate the area of the base triangle ABC. So we can observe that we have this side, and we have angle between them. So we can use our formula for the area of triangle. So 1 over 2 times A, so 12 or 14, it doesn't matter because here we have multiplication, and sine 80 degrees, and we have to calculate our area, and area is 82.7 meters squared. B. Find the angle between the edge AD and the base plane ABC. And we know that our point D is directly above our point A. So we can observe that the line AD is perpendicular to this triangle, so to the plane ABC. So the angle between a line perpendicular to a plane and the plane is 90 degrees. So this angle is just 90 degrees without any calculations. And you see we have to calculate the length of DC. So this length, we have this one, we know that they form right angled triangle, so we can use Pythagorean theorem formula. So just 10 squared plus 14 squared equals x squared. So x equals square root of 10 to the power of 2 and 14 squared, and we can calculate it on our GDC. This is 17.2 meters. Problem 5. The height of a Ferris wheel above the ground can be modeled by h equals 22 plus 18 sine and in bracket pi over 15 times t, where h is the height in meters at time t minutes after the ride begins. A. Find the maximum and minimum heights of the Ferris wheel. And the easiest possible way is just to type this function into our graph function on a GDC and then choose gsolve, maximum point and minimum point, and we will have these points. So our maximum height is 40 meters and minimum height is 4 meters. B. At what time after the ride begins is the passenger first at a height of 35 meters? So now we're looking for the time, and time is t, and we are given height, so we can just substitute 35 as h and then look for t. So you can simply find it on solver or on our graph function. You have to choose gsolve, then x calculate, and then enter y value, and our y value is 35, and we have x, so our t time 3.85 minutes, and we can convert it into seconds, because 3 is of course our 3 minutes, and we have to convert this into seconds. So we just have to multiply 0.85 with 60, and this is 51. So 3 minutes and 51 seconds. C. The ride operator wants to ensure passengers do not stay above 30 meters for more than 5 consecutive minutes. Does this model satisfy that condition? So first thing that we can do is just to go into our graph function, and we have to check when we have the first time when our y, so our height, is 30 meters. So we have to look for x, and in our case t. However, on our GDC is x, so we're looking for x, and our y value is 30. And we know that we can observe from our GDC that first 30 meters is at x 2.20, and the second x is at 12.8. So we can subtract them. So our answer is 10.6 minutes, which is of course greater than 5 minutes that this operator wanted. So this model doesn't satisfy that condition. Problem 6. Two airplanes leave the same airport at the same time. Plane P flies on a bearing of 40 degrees and plane Q flies on a bearing of 130 degrees. After flying 600 kilometers each, they stop for refueling. A. Using trigonometry, calculate the distance between the two planes after their flights. So let's firstly draw our situation. We are starting in here, and we know that when we have bearings, we have to draw a straight line into north. And the first plane, plane P, flies on a bearing of 40 degrees. So we know that in here it would be 90 degrees. So 40 degrees is maybe in here, more or less. So our airplane P is in here. Here we have 40 degrees, and here we have distance of 600 kilometers. And the second plane, plane Q, has a bearing of 130 degrees. So we know that here it will be 180, so 130 is more or less in here. So 130 degrees and also 600 kilometers. So here we have our plane Q. And also we know that this angle is right angled, because we have to subtract from 130 40 degrees in order to calculate this angle, and this angle is right angled, so 90 degrees, and we have to calculate the distance between the two planes after their flights. So basically this distance. So of course we can use we can use the cosine rule that looks like this. We have to substitute our values. So we have c squared equals 600 squared plus 600 squared minus 2 times 600 times 600 times cosine of the angle between them. So we have to be careful because we have to take only this angle, so our 90 degrees, and now we have to calculate it, and C is 848.55 2 kilometers. B. Find the bearing of plane Q from plane P. So firstly, we have to decide for which angle we are looking for. So we know that we have bearing of plane Q from plane P. So we are starting from here. So let's draw a straight line for north, and from plane P to plane Q. So basically this is the angle that we are looking for. And we have to decide what we want to calculate firstly. Because we know that this angle is 90 degrees and we know that these sides are the same, it means that these angles are also the same. So we know that the sum of angles in triangle is 180. This one is 90, so we're left with 90 degrees. That has to be divided into two angles. So 90 divided by 2 is just 45. So this angle is 45 degrees, and this as well. So this is the first thing. Then we have to think about something else. What we can do? Of course, we can make the triangle in here. Of course, here we have 90 degrees. Here we have 40 degrees. So here we are left with 50 degrees. And here we have a straight line, and here of course. So here we have also 90 degrees, our right angle. So in order to calculate our alpha, we have to subtract from 180 degrees, 45 degrees, 50 degrees, and 80 degrees. And our alpha is equal to 175 degrees. And that's our final answer. It was the last problem from this topic, trigonometry, and if you found this video helpful and useful, please share this video to your friends. You can also leave thumbs up, subscribe to my channel, and if you have any questions, you can write them down below in the comments or via my mail. That is, as always, in the description of the video. See you!